inch blast hole pattern that was drilled up here on the west side of the pit. And what we're trying to do is a little hole wall blast hole stabilization work today. These are holes that were here that were drilled with 6 3/4 inch tricones, and we're going to give you a bit of an example of what we've done to improve this. This is a fairly typical hole collar. As you can see, it's rough, actually pretty dry, very friable, ability to slough in. These holes are all wet. Really can't see the water, but there's water in all of these at about 10 or 16 feet, somewhere in there. As you go along, you can see the washing effect that bailing the water with the cuttings has done here. And these hole plugs are 3 to 4 feet deep into these holes. See the quality of the cuttings themselves. Pile is dry for the most part, and again, quite friable. Some of these holes demonstrate the difficulty of collaring in that they've had here. All pretty typical. You can see that some of them have sloughed radically into these holes, and you've just seen what was done with conventional water injection. Now we'll show you a few holes that were drilled with D5 on the same pattern using the hole wall stabilizer. You can see that's a nice, neat gun barrel bore hole. The material is bonded together on the top. As this dries, it's going to set up and be real stable. Another hole, you can see that there is a totally different look to the cuttings in the stemming pile. And there's a row of holes here that were collared in quickly and easily, drilled to depth. One of the questions that Wyatt asked me was how I was going to do in water, and these holes are all drilled in a saturated area of the pit here that's got groundwater standing in these holes at about 10 feet. You can see the nice, neat collar. The hole is a real precise diameter, 6 3/4 down through the sub-drill, place where they've always had problems here before. The texture of the cuttings is totally different. They're a lot coarser. I don't know if the tape is showing you how encapsulated the fines are with the bigger cuttings. If you ran this through a sieve mesh, you'd find that you had an average larger size of the cuttings here. These holes are probably being drilled a little quicker, a little more efficiently. We've increased the viscosity of the bailing medium, therefore it's lifting a lot of these cuttings out. Cleaner and neater, giving you a bonding effect. We're literally gluing this stuff together. What we've got here are the sample sacks from the last 2 holes drilled. These are the cuttings from the first hole using the standard water injection. This was D2 Drill-Tech rubber tire D40 cage, 6 3/4 inch hole. You can see the fineness of the cuttings, how that bit has to regrind them to fit them with the available bailing capabilities of the compressor. And this is the second hole. You can see there's quite a difference as far as mesh size of the cuttings. The encapsulation is very obvious though.